heat of reaction, also known as Hess's law. Hess's law is actually very extensive. We're going to kind of do a qualitative overview of it right now. But this is basically the energy that's contained within one reaction. We talk about it as the quantity released and absorbed because we talk about it as a whole. So it's sort of like the net energy at the very end. We express it by putting it in the equation. So you can see where it says B expressed with thermochemical equations, and then A, it gives us the equation for the formation of water. And then it has 483.6 kilojoules. Now, the heat of the reaction, or Hess's law, this enthalpy H, or enthalpy, this delta H, which we also call enthalpy, that's what we see here in the reaction. However, enthalpy is measured per mole. It should be energy per mole, so kilojoules per mole. This actually isn't per mole because we have 2 moles of water that are formed, so half of this would be for 1 mole. So when we write enthalpy, or when you're calculating enthalpy, you calculate it as kilojoules per mole. So when you look up an enthalpy, that's something you can look up. It's like inherent of every single formation or combustion reaction. And when you look it up, you're typically going to see like per mole. So if you have more than 1 mole, you have to multiply it by that. But again, we're going to think about this more conceptually than anything else. So the delta, the triangle, just means that it's a change. So this is the enthalpy of the products minus the enthalpy of the reaction, or reactants, gives us the enthalpy of the reaction, the total energy contained in that reaction. So you can see in like the picture down below in A, in this first part over here, we're tracking the enthalpy of the reaction like over time. You might have seen this chart before. Actually, I'm not sure if we have or not. But basically, the energy of the reactants lies here, energy of the products. This is the activation energy. It's the reactants to our activated complex, which is a point at which like all the molecules are broken up, but none of them have been rebonded yet, right? In a chemical reaction, the reactants break apart and then they form the products. So when they're all broken apart, that's the activated complex right up here. It requires the most energy. You always have to put energy into a reaction, and you will always release energy. The difference between how much you put in and how much you released is the delta H, is the enthalpy, and that also helps us determine if something is exothermic or endothermic. So here you can see that we put in a lot of energy, but then we released way more. That means that this is an exothermic reaction. I can tell by the graph because I released more energy than I put in. The difference between where the reactants, the energy of the reactants started at, and the energy of the products, that's the enthalpy. So when I said you take products like minus reactants, that is the enthalpy. Now, in this circumstance, the enthalpy is negative, which is how we know it's exothermic. Here in the second, in B, I put in more energy than I released. So when I do products minus reactants, I'm going to get a positive number. So endothermic is a positive enthalpy and exothermic is a negative enthalpy. I think I wrote that on a slide somewhere, but we'll see. Energy released and absorbed. Okay. So earlier I said there's the enthalpy of formation, and there's also the enthalpy of combustion. And combustion's a little more complicated. I didn't want to go into the whole thing, but formation is pretty simple. You guys just saw a formation reaction, which is a synthesis reaction, right? We have an element plus an element yields a compound. So a synthesis reaction, you can see formation of something like benzene, ammonia. They all have enthalpy. Notice again, it's kilojoules per mole. Anything on here that's negative means that that's exothermic. Anything on here that's positive means that it's endothermic. It takes energy. It takes more energy than it releases. That's endothermic. And then exothermic would be releasing more energy than it takes in. So every like compound on the entire planet, you see water here. You even see water versus water vapor. So based on their state of matter, their enthalpy will change a little. So this is the standard enthalpies. When we say standard, we mean 25 degrees Celsius and 1 atm. That's not the same thing as STP, but when we're talking about a standard state, we are talking about like their their state, sorry, their state at 25 degrees Celsius and 1 atm. Okay. And then, so what does Hess's law actually state? It's the overall change in enthalpy. So like I was describing before, taking the products minus the reactants, we want the overall change is what the enthalpy is. So if I were to give you reactions on how to form that, you would we have this formation reaction here. We have another formation reaction here that we then flipped. So this one was probably originally negative and we flipped it so it became positive. We added them together. We got our final formation reaction and we figured out our enthalpy. You guys are not going to have to do this part. I just wanted to show you an example. So if you ever see it again, it's not going to be too unfamiliar. But again, enthalpy is products minus reactants trying to determine the overall change in energy. We will be taking Hess's law. We will be applying it, not necessarily mathematically, but definitely conceptually. We are going to move into energy calculations where we calculate energy. So we calculate kilojoules, and then, or actually, we're technically going to calculate joules, and you'll convert to kilojoules. And then I'll ask you for the enthalpy, in which case you'll use the mass to find the moles and do one more additional calculation. Just conversions. You're not going to have to do anything like what you see on the screen now, but you will have to do some mole to gram or gram to mole, technically, conversions in order to find the enthalpy of a reaction. We are going to work with the equation Q equals MCAT, which you guys will see in the examples in your notebook.